right, welcome to your last recap video for the AP Calculus exam. I know it's pretty sad that this is the last time we'll be spending together in these review scenarios. I'd like to point out that recap 6 number 1 was posted before Mr. Lakin's recap number 5. Just gonna point that out. I have a degree in technology, and sometimes Mr. Lakin struggles with the upload to YouTube. But it's all done, it's all there. And also Mr. Lakin gave me permission to mock him. So, yeah. All right, we're going to go through these first 3 multiple choice questions together, and then the free responses you're going to kind of try, and then I'm going to talk through the scoring rubric, and we'll go through and kind of explain where the point breakdown would apply to your problem. So, to start, which of the following is the solution? So we're looking for a curve y equals to the differential equation, this means derivative, equal to x squared over y with the initial condition y of 3 equals negative 2. So we know that our function needs to go through the point 3, comma, negative 2. Well, to start, the first thing you want to do is separate your variables. So I'm going to multiply by y on the left and dx to get that to the right. So you could use the phrase cross multiply. I don't love that. Really, you're multiplying by y and multiplying by dx. All right, so from here then, to get the differentials to go away, this, by the way, is a +1 on the multiple choice free response. We're going to integrate. This is going to become y squared over 2 equals x to the third over 3 plus c, and c just showed up on the scene. So I'm going to use my initial condition, and I'm going to plug in negative 2 for y, so this will become 4 over 2 equals 27 over 3, which is 9, plus c, which means that c is equal to negative 7. So then I want to go back to that part where I took the antiderivative. This will become y squared over 2 equals x to the third over 3 minus 7. I was supposed to solve, though, for a particular solution, so I'm going to get y by itself. So that's going to be y is equal to plus or minus the square root of 2x to the third over 3 minus 14. Well, this is all well and good, except I see the positive version here and the negative version here. And the way that you can distinguish is your point was supposed to be 3 comma negative 2. So if I put a 3 into here, I need to have a result that is negative for a y value. So E is going to be our final answer, particular solution. All right, question 2. Shown below is a slope field for which of the following differential equations? And this says you're not supposed to use your calculator. So looking at this, the first thing I would want to establish is, do we have symmetry along either the rows or the columns? And unfortunately, we don't. So the next thing to think about is, do we have any symmetry within the quadrants? Well, we don't. We can't just say, well, no. This quadrant, we've got all negative slopes. All right, that's kind of helpful. This one, we've got all positive slopes. That's kind of helpful. But then in this quadrant, we get some positive and some negative. But it looks like we've got some interesting stuff going on here at negative 1. So where x is equal to negative 1, it appears that our dy dx needs to be equal to 0. All right, so let's think about that for a second. Anytime that we plug in negative 1 for x, we need to have a slope of 0. Well, if I plug in negative 1 here for x, I would get 0 only when y is 0, so that's not going to be happening. This one, if I plug in negative 1 for x, I end up with negative y minus y. That's not necessarily 0. This one, if I plug in negative 1 for x, I get negative y plus y. Ooh, that's equal to 0. I'm going to keep that one in mind. This one, if I plug in negative 1 for x, I would get negative y minus 1. That's not guaranteed to be. And this one, if I plug in negative 1 for x, I get 0. Negative 1 plus 1 to the third, right, is going to get me 0. So I've got these two going on. But I said earlier I didn't have any symmetry in my rows or in my columns. This would only be dependent on the x value. And if I look, for instance, when x is 1, I don't have symmetry along this entire column. It was only when x is negative 1 that I see that symmetry happening, in which case I know my slope field is supposed to depend on x's and y's. My answer choice should be coming out as C. Now, you could also go through and you could do some actual integrals and find the equations themselves, but I think that just thinking about your symmetry, finding those key points, in this case the fact that x equals -1 had a result of 0, should get you there. All right, last one. What is the area enclosed by the curves? You can't see because my face is covering it. Those two graphs. So if you graph these on your calculator, because it does say you get your calculator, you are going to see a nice Disco Man graph. That'll be this one in black. And then the line in red that you can't see but is on your paper is going to do something like this. So we're going to be looking for this yellow area plus this green area. And so when we do this, we're going to need to integrate two separate integrals and add them together. So thinking about this, these are going to intersect, if you use your calculator intersect feature, at 1, at 2, and at 5. So I'm going to integrate from 1 to 2 of the cubic minus the line. How do I want to indicate that? We'll go y minus that y. I don't love that. Back up. If I left myself more room, we're going to do the x to the third dot 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 minus the linear of just x plus 5. This one then we would do the x plus 5 is the top curve minus the x to the third dot dot dot, and that's going from 2 to 5. Using fint on your calculator, take a second to do that. Pause me while you type in all that information. Yes, actually press pause. All right, and we should have answer choice B. If you didn't get that, double check how you are breaking up your integrals and make sure that you are integrating from 1 to 2 and then from 2 to 5. All right, this next one, question 3, this is from 2011 B. Go ahead and label that. This question 6 is from 2003 Form B. And then this question 6 with the slope field is from 2004, 1 year older than me in high school. And we're just going to talk through these for our answer keys, okay? I know this isn't necessarily maybe what you had hoped for in terms of the review for differentials and slopes, but that first review video was really supposed to get you all of the important information, and then hopefully you can apply it to these problems as we're working. So this one starts with our 2003 B, question 6. First one says to find f double prime of 3. Well, before you can get to f double prime, you got to get through f prime, so you're going to use a chain rule there. So you get 2 points for accurately getting f double prime. And then the second part is actually plugging in 3. So when you plug in 3, you would not have had a calculator for this one. So when you plug in 3, you got to make sure that you can get to that 19/2, although technically this is an okay answer, right? It's all in terms of numbers, no variables left, so you should be good. All right, this is the one where I really want to get at the heart of these differential equations. This point breakdown is pretty consistent across APs when these questions come up. So you get 1 point just for getting your x's and your y's on one side. Then you'll get 1 point for taking the antiderivative of this side, another point for taking the antiderivative of this side, and you get an entire point on a free response question for writing plus C. The next part then is your ability to find C. That's what this uses initial condition is indicating. Then you get 1 point for solving for y, so making sure you can get to your final answer. Okay? Then these little notes, again, this is pretty consistent. If you don't do plus C, you get 50%, and that's it. If you don't separate those variables at the beginning, just getting the x's on one side and the y's on the other, you get nothing. Nothing. Even if you could do the calculus correct, you've got to separate your variables. Every time. Start by separating your variables. All right, for the next one, I want you to pause and I want you to try it on your own and then come back to me so we can do the answer key for it. Sorry, I realized I didn't clarify. You should be trying question 6, the other one from 2004, to go over what we just practiced and see if you can get A, B, and C done correctly for those. So go ahead and pause your video and try question 6 that has a slope field. Pause it, don't just wait for me. All right, drawing a slope field. Remember when we talked in class, it's more about the general relative steepness, as long as you have your zeros where they're supposed to be, and you've got positives, positives, negatives, negatives, etc. But in terms of like, are they going to measure the slope? No, they're not going to take the time to care that much in detail. So if you notice these 2 points, you get 1 point for having the correct zeros. So zeros along when y is 1 or when x is 0. And then you get a second point for having positive slopes up here and negative slopes down here. Okay, so 2 points for part A. Part B, it asks you to describe the part of the xy plane. Well, hopefully when you look at this, you say that I have positive slopes, well, anywhere that's greater than 1, but not along 0. So where y is greater than 1, but x is not equal to 0, that's where the rest of the coordinate plane is going to have positive slopes. All of these ones down here then are going to be negative. And again, if you struggled with finding those slopes, you just want to plug in your points 0, 0, 0, 1, 0, 2, 1, 1, etc. into that differential equation. All right, notice again we have our 6-point breakdown. So 1 point for separating your variables, 1 point for this natural log showing up, 1 point for this cubic, and 1 point for a plus c. That gets you those 4 points. If you did not get any of those 4, you need to stop where you're at because they're going to stop grading. If you did get those, the next thing then is use as initial condition. So did you accurately find a c value? Now your c value might be different than what they show here. So what I'm going to say is for your final answer, when you solved for y, if it looks like this, then you would have gotten your c value. So I tell you to find c as soon as it shows up on the scene. And remember, you don't always have to do that, but you're safer to do that. So sometimes AP scoring rubrics look a little weird because they find a different, in this case, k value, right, than we would have found for c. But as long as your final answer solved for y, because it says to find the particular solution, y equals f of x, so you got to have y isolated. As long as that comes out looking the same, then you are good. All right. Oops, too soon. Next one, go ahead and pause me again, and you are now working on our area and volume question. You do not get a calculator for this one either. Question 3 from that year, no calculator. Pause me. All right, I got 3 minutes to get through this one. I'm going to integrate f of x, and from 4 until 6, we're going to integrate g of x. Doing that by hand, you should end up with 22/3 or 7 1/3. Double check now with your calculator. I know you didn't get it while you were working, but you should double check, and if your long numerical answer matches that, you can leave things unsimplified. But hopefully you know that if you plug in 4, right, 4, square root of 4 is 2, 2 to the 3rd is 8. You can use that kind of logic, right, with your roots and your powers. This one right here, when you integrate the line, right, this is just a triangle. No need to do any sort of crazy calculus going on. Just use geometry to help you. Part B, you are finding a volume perpendicular to the y-axis. So immediately I would set this up. And it says that we're supposed to have rectangles. Well, rectangles have an area of base times height. It tells you that the height was 2y. So your goal then is to figure out the length of the base. Well, if we're cutting this way to this way, you're talking about g minus f, but you've got to be solved in terms of y values. So we're going to solve this one, 6 minus x, to now be 6 minus y, minus your y squared when you solve this one. So your base is 6 minus y squared. Because you're integrating against y, you're going from 0 until this y value where they intersect, which is 2. Okay? And I think it says, right, but do not evaluate. So yeah, just your integral is all you're looking for. And then the last part, it says that there is a point where the graph of f has a tangent line. So f prime is going to be equal to the perpendicular slope of g. Well, the slope of g is -1, so the perpendicular slope is 1. So f prime needs to be equal to 1. You're going to solve, you get 1/4, and then you get the actual coordinate point. You'd plug 1/4 into your equation to figure out the point P for which it happens. All right, so again, those were kind of quick, but at this point we should be feeling pretty good about the concepts. It's just about applying them. If you have any questions at all, you can come back to this video, look at the scoring rubric a little more closely. Also, Khan Academy has great videos with area and volume and differentials and slope fields, so make sure you feel really good on these last 2 chapters from AP Calculus. That's it, you're done with